Hi, I'm Alex Pault, and I'm here at Publitech Connect with Mark Pinto. He is the CEO of Dukosi, and, we're going to talk a little bit about batteries. Isn't that right, Mark?
Yes, thanks, Alex. Glad to be here.
Well, batteries, there's so much going on between the chemistries, between the management, the devices themselves, the monitoring of the devices, communicating that to the system. There are so many moving parts in there.
Yes, and many applications that are being enabled by these things today and limited by them by performance, cost, and safety. So we're trying to address all those issues.
Well, let's tackle them one at a time. Right off the bat, performance. That's the big buzzword that everybody's talking about today. And that can be anything from the chemistry of the battery to how well it's being managed and monitored and all of that other. Where do you dive into that?
So what we're doing, when you talk about a battery, like for instance in a car, it's actually maybe 100 or 200 cells. And so the battery only performs in some sense as well as the worst cell of the 100 or 200. And so what we're trying to do is monitor every single cell and optimize the performance, the cost, the safety of all of those cells. So we know what's going on in every one of those 100 or 200 cells. And that helps make the battery safer, but it also helps it perform better because we know where the worst battery is at any particular time and how to adjust the whole system on that basis.
Now, there are other solutions out there that do battery management, they're monitoring the cells and all of that other. How would you distinguish your solution from what's out there in the industry?
The difference is that we're doing everything at the cell. And so this is not, we didn't invent that idea. People have had the idea of understanding what's going on a cell by cell basis. The problem is when you do that, how do you get all that data out of the battery? You have 200 cells in there. How do you get all that data? Let's say you want to measure temperature, voltage, current. You have a lot of wires that you're going to have to set up. Those wires cost, first of all, cost. They affect accuracy. They affect safety. You got all the solder joints of all those wires. So it's been weight, very good, and so it's been impractical. It's a good idea, but it was found to be impractical. So the current solutions just don't do it. They only measure a single thing, typically voltage on each cell, and they do it with a single chip inaccurately because every cell has a different length of wire. You have to take that into account. What we've done is we figured out a way to get that data out cheaply, accurately, synchronously on every cell. So we know voltage, temperature exactly at the same microsecond on every cell at the same time. And we did it through the same technology you use in your, to use Apple Pay, near field communication.
So it's an NFC solution.
Yes, it is. But it's a network running over NFC.
So it's basically like kind of a mesh network within your battery that's talking to itself and each other.
Exactly. And so every cell is doing its measurements, and it puts its data packet on the NFC. It gets to a central processor, and the processor knows that all those measurements were made on all of the cells at exactly the same time. So when it does a calculation, it can precisely know what's going on in that battery at every time instant.
You're using the NFC within the battery pack, and then how do you get that data from the battery pack to the microcontroller?
Well, that's standard. So there's a board at the edge of the pack. What we've been able to do is no matter how many cells you have, you can reconfigure it with, if you have a car that has 100 cells, 150 cells, doesn't matter. You just hook it up with the NFC, with the antenna, and we get it back, and then we give it to the processor as if it was wired, but it's not.
It's not, but the fact is it can still operate, and there's no issues with lag or...
None. And so through that, several things happen. One is safety. So on a safety, we know the temperature on every single cell and every microsecond. So in the alternative, because they can't put wires for temperature on every cell, is typically in a battery pack they might at most have 3. And so when a temperature of a cell starts to rise somewhere, unless it's right near the temperature sensor, you won't know about it for 10, 15 minutes. We know instantaneously that the temperature changed. So from a safety point of view, it's much safer. Also, though, from a point of view, when you're in a car in an EV and you see how many miles you have to go, it's doing some calculation, state of charge calculation, but it's very inaccurate because you don't have the level of accuracy that we can get by putting a chip with processors right on every cell and doing higher precision calculations.
Well, and then one of the nice things about it being a wireless solution within the pack is in case of, heaven forbid, a vehicle accident, you don't have a lot of broken connections inside.
No, also, but that's true. But also, typically those solder joints are a huge failure, source.
Even under normal circumstances.
Exactly. So we eliminate all of that. The other thing is our chip, because once you get a chip there's a lot you can do with it. Microelectronics, the costs have gone down dramatically. So we have memory on every chip, embedded non-volatile memory. So the memory, you can use it. The first thing is, as soon as the chip is manufactured, as soon as there's a voltage on the cell, the chip starts working. So in the manufacturing line, it can start working. It can know how it was manufactured, where it was manufactured, what process it went through. It knows how it was shipped. Then you start using it. It knows how it's been used.
Like a black boxes.
Yeah, and it just stores all that. So you can use that information in Second Life, for instance, in sustainability to determine. You can use it to determine, can you actually ship this battery safely on an airplane or what have you. As a buyer of the battery, you can know how good is this battery. You can be assured, because you go to the store today and buy cells. Do you know they're any good or not? You don't really. You're trusting the name on the battery, but you don't really know. This will tell you, what's going on with that cell. You can query it and know, if you're a auto manufacturer, this cell is good.
Is it a purely monitoring aspect, or is there also some control aspect to it? Can you also use the chip to manage the cell in case there is an issue, so you can address it before it becomes a problem?
Absolutely. But we interface with a processor that we don't make, that others do, that make those decisions. But we give them the data to make those decisions, and we can do our own calculations on the cell so that they don't have to process all zillions and zillions of bits and every millisecond. So we give them the summary, whatever the customers think are relevant. And by the way, that's going to change going forward. One of the things about batteries is academics, whatever, researchers don't even really understand a lot of the basic mechanisms of batteries and what are the failure mechanisms, how you can tell. So what we're giving the engineers, the battery engineers, is the capability of measuring, adding new things. Like, for instance, one of the things people talk about, maybe acoustics will help us determine if a battery is starting to wear out.
Piezo noise or something.
Exactly. RF noise is another one that people have been researching that gives you a faster signal than, say, just measuring the resistance of a battery. So think about it. You measure the resistance of a battery, you're measuring huge amount of averaging, right? But if you're measuring noise, that's little events going on inside, the battery. That may be a better signature that something's going to happen. So we think over time, once people can have a chip on the battery, there's all kinds of things you can do with it and sense, as I said, acoustics, noise, temperature, current, voltage, do some calculation and determine really what's going on.
Very cool, Mark. Now, is there any aspect of the system that we haven't talked about that you wanted to bring up for the audience?
No, I think the most, it's one of these things where people will say, well, you're trying to put a chip on every cell and it doesn't make economic sense. I think one of the things with this is there's a payback instantaneously. We get rid of all wires. You get, better energy, better delivery, better range. You have to use fewer cells. So it actually is one of these things that you get everything, actually. The challenge for us, we're a startup, is twofold. One is that even if we were bringing a proven technology to market, the design cycles in these kinds of products are slow. And so it takes time for customers to get them into these kinds of products. The second thing is when you bring something new, people want to see that it works before they even get to the stage of, investing a year or two to put it into a product. What's happened with us, and today we've announced we've gotten through that first hurdle. We've tested this in markets like marine, industrial, transportation, cars, the battery storage, energy storage systems, shown that it works in rigorous testing. And we've qualified the chip. So now we're at the point where it really can be put into production.
Very cool, Mark. Now, are there any other things you wanted to leave our audience with, a tip or advice, or talk about the industry a little bit, or whatever?
We're as with many other things. You look at things like solar energy, whatever. We're going to learn as engineers more about how these things work, how to design them better, and costs are going to continue to come down. And so, it's inevitable. Is the EV going to be more affordable? Absolutely. And it's through innovations like this, that we're making and others to help, make these things more cost effective and adoptable by, everybody worldwide.
Very cool. Thank you so much, Mark, for taking the time. Yeah, I've enjoyed it myself.
Thanks.